Hello everyone, welcome to lecture 7. Today we will study natural exponential functions. So let's try to understand what a natural exponential function is. So in my last lecture, I taught you about the natural logarithmic function. So the natural logarithmic function fx equal to ln x, right? So you all know that its domain is 0 infinity, right? So you can take x only in this interval, right? And you also know that its derivative is 1 over x. So since x can lie only in the interval 0 infinity, so this derivative is always positive, right? So the derivative of y equal to ln x is always positive. So what does that mean? The function y equal to ln x is always increasing. So it is always increasing means, so fx equal to ln x is always increasing. Now what does it means that it is always increasing? So fx equal to ln x is always increasing means fx equal to ln x is 1 to 1. This we know from what we have studied in the inverse function chapter, that if a function's derivative is always positive or always negative, that is the function is always increasing or always decreasing, then that function is 1 to 1. Now if a function is 1 to 1, what does that mean? It is invertible or its inverse exists. So fx equal to ln x is invertible. Is invertible, that is its inverse exists. Its inverse exists. So the inverse of the natural logarithmic function is called the natural exponential function. So this is how we define a natural exponential function. The natural exponential function is just the inverse of the natural logarithmic function, which we have studied in the last chapter. Right. So this is the definition. The natural exponential function is denoted by e to the power x. This is the symbol we denote, and it is defined to be the inverse of the natural logarithmic function ln x, right? So since e to the power x is the inverse of ln x, so we know that a function and its inverse will cancel each other. So we have these properties. First, that ln e to the power x is equal to x. That is, if I have ln, then if I have e to the power x, ln and e will cancel each other and I will be left with x. In the same way, I have e to the power ln x, that is also x. These two follows from the fact that the e to the power x, it is just the inverse of ln x. In the same way, we have another property which also follows from the fact that e to the power x is just the inverse of ln. If I have y equal to e to the power x, right? So if I have, let me write it down so that it becomes more visible. If I have y equal to e to the power x, then this statement can also be written as x equal to ln y, right? So you can understand it in this way. So if I have y equal to the power x, as if I take this e there, it will become l. So I can write it in this way to make it more visible. So this statement is same as ln y equal to x. So this also follows from the fact that e to the power x is the inverse of ln x. So if I have a statement like this, y equal to e to the power x, I can take this e on that side, and when I take this e on that side of the equal sign, it becomes ln y. So in the next step, ln y equal to x, right? And this you can understand, you can prove this using these two inequalities only. You see that if I apply ln on both sides, so if I have an equation like this, so if I am given like this, if I apply ln on both sides, I have ln y equal to ln e to the power x. Now this ln e to the power x, they will cancel each other using this property, and I'll be left with ln y equal to x. So y equal to e to the power x implies ln y equal to x. So these three property you have to remember. One is ln e to the power x is x. That is, if I have ln and then e to the power x, they will cancel each other. I'll be left with x. E to the power ln x, this is x, and this conversion y equal to e to the power x can be written as ln y equal to x. Now let's study how the graph of natural exponential function would look like. So this is how the graph of y equal to e to the power x looks like, right? Now one beautiful thing about the graph of y equals to e to the power x is that this graph you can obtain from the graph of y equal to ln x as follows. If you recall, what was the graph of y equal to ln? The graph of y equal to ln x was something like this, right? So if you know the graph of y equal to ln x, you can obtain the graph of y equal to e to the power x just by reflecting about the line y equal to x. This is the line y equal to x. So if you place a mirror along the line y equal to x, and if you reflect, so make it more visible. So this is the line y equal to x. So if you take a mirror and place it along the line y equal to x, and if you reflect y equal to ln x, you will have the graph of y equal to e to the power x. So y equal to e to the power x and y equal to ln x, they are as if they are the mirror images of each other if the mirror is placed along the line y equal to x. This is a beautiful thing about the graph of y equal to e to the power x. So I can write down in this way: the graph of y equal to e to the power x can be obtained from the graph of y equal to ln x by reflection about y equal to x, right? Now let us study some properties of natural exponential problems, not natural exponential function, which will be helpful in solving problems. So properties of natural exponential function. Okay, so the first property is the cancellation laws that we have just studied. The cancellation laws are these two beautiful laws: ln e to the power x, this is just x, and also e to the power ln x, this is also x. These are the two cancellation laws. Then we have the inverse properties that also I have stated. Inverse property. So the inverse property is y equal to ln x. From here I can write, or you can write in this way: y equal to e to the power x. From here you can write ln y equal to x. So as if I take e on that side, it becomes ln. Third property is the derivative. So ddx of e to the power x is e to the power x. So the derivative of, this is a very important property. So if I take the derivative, so the ddx of e to the power x, this is equal to e to the power x. So that derivative of e to the power x is equal to e to the power x. This is a very important property. And the last one is integral of e to the power x dx is also e to the power x. This is the last property. So these four properties have to be used in solving the problems. Okay, so the first properties are these two cancellation laws. Let me write this A, B. A is ln e to the power x is x, e to the power ln x is x. Okay, then this is the inverse property. If I have y equal to e to the power x, I can take this e on that side, it becomes ln y equal to x. Right? Third property is derivative of e to the power x is e to the power x. Fourth property, integral of e to the power x is e to the power x. So these are the four properties of e to the power x, or the natural exponential function, which we will use to solve the problems. Let's now go straight to the problems. solve the following equations for x. Okay, so the first one is ln x equals to 5. So we have to solve this equation. So how to solve this equation? So remember, whenever you are given an equation and you need to solve it, you have to, basically it means you need to use one of these two cancellation laws. Either ln e to the power x is x, or e to the power ln x is x. Now which one to use depends upon the scenario. For example, you see that, so here I already have ln x. So in order to cancel this ln x, I need to bring exponential function. So that means I will have to apply this. So what I do is that I raise both of them to the power e on both sides. Okay, so in the next step what I do is e ln x equal to e to the power 5. Now you see e and ln x. So by this law it just becomes x. So x equal to e to the power 5. So E is the required solution. Okay. So solve means to find out the value of x. So how to solve? The technique is see what is there. So if you already have ln, then apply e on both sides. If you have e, then apply ln. Okay, so in the first problem you already had ln, so I have raised e on both sides. Now e power ln x just gives you x, so x equals to e to the power 5 is the required solution. Now let's take the next problem. E to the power 3x plus 1 equal to k. So here already I have e, so I will apply now ln on both sides. So if I apply ln on both sides, I get ln e to the power 3x plus 1 equal to ln k. Now you see I have ln and I have e, so they will cancel each other and I will be left with 3x plus 1 equal to ln k. So solving it, I will get, if I subtract 1 on both sides, I will get 3x equal to ln k minus 1, and then if I divide by 3, I will get x equal to 1/3 ln k minus 1. Now let's take the next problem. E to the power 5 minus 3x equal to 10. So here already I had e, so I will apply ln on both sides. If I apply ln on both sides, so ln e to the power 5 minus 3x gives you ln 10. So ln and e will cancel each other. So I will be just left with 5 minus 3x equal to ln 10. So to solve this now, I get 3x equal to 5 minus ln 10. From here I get x equals to 1/3 5 minus ln 10. So this is the required solution. Now let's take the next problem. Which is ln x plus ln x minus 1 is equal to 1. Okay, so for this, to solve this equation, first we will have to use the property of ln x, namely ln xy equal to ln x plus ln y. Recall this property from my last lecture, that if I have ln x plus ln y, I can write this as ln xy. So using that, I can write ln x plus ln x minus 1 as ln x times x minus 1. Now I can raise e on both sides and write down this as e power ln x times x minus 1 equal to e raised to the power 1. Now finally you see that e and ln will cancel each other, and I will be left with x times x minus 1 will be equal to e. Now I can solve this equation. This will be x squared minus x equal to e. So this is a quadratic equation. You can take e on one side. You can write this as x squared minus x minus e equal to. Now you need to solve this quadratic equation. I hope all of you know there is a very good formula by which you can find out solve any quadratic equation. Recall that if you have a quadratic equation of this form, ax squared plus bx plus c equal to 0, if you have a quadratic equation of this form, the solution of this quadratic equation is given by this formula: x equals to minus b plus minus b squared minus 4ac by 2a. This is the formula by which you solve a quadratic equation. If you know that a quadratic equation has this form, you know the coefficient of x squared, you know the coefficient of x, and you know the constant term. You can just put the values of a, b, c and solve this quadratic equation. So here also you have a similar quadratic equation. So compare this quadratic equation with this. So what is the value of a here? The value of a here is 1. The value of b here is minus 1, and the value of c here is minus e. So just put down these values and find out the value of x. So from this equation we get the value of x is minus of minus 1 plus minus b square is minus 1 whole square minus 4ac divided by 2a. So I get x equals to 1 plus minus 1 plus 4e by 2. So this is the solution to this equation, that is x equals to 1 plus minus square root of 1 plus 4e by 2, and I have obtained this using this formula. Now let's take the next problem. Solve ln x equals to 1. You need to solve this equation. So how do you solve it? Very easy. So first you apply e on both sides. You get e to the power ln x equal to e to the power 1. So this e and this ln will cancel each other and will be left with ln x equal to e. Now I will again apply e on both sides. So e to the power ln x equal to e to the power e, right? Finally, this e and ln will cancel each other. I will have x equals to e to the power e as my answer. Finally, the last problem from the first part. E to the power x equals to 10. Okay, so first I apply ln on both sides. E to the power x equal to 10. If I apply ln on both sides, I get ln e to the power x equal to ln 10. Now you see this ln and this e will cancel each other, but the top e will remain. So I will have e to the power x equal to ln 10. Then I again apply ln. Then ln e to the power x is finally ln and ln 10. Then finally this ln and this e will cancel each other, and I will just left with x equals to ln 10. So it's just about applying ln and e appropriately so as to cancel. So I had e to the power x. First I applied ln. This ln will cancel the bottom e, and I'll have this e to the power x equal to ln 10. Then to cancel this e also I apply ln again, so that I get x freed, because to solve an equation means to free x. So that's what we do in all the problems. At the end we free x, and whatever once we free x, whatever the value you get is the solution. So this is the first type of problems that can come from this chapter, solving an equation. Now let's do the other type of problems that can come. Differentiation of functions of exponent e to the power x. So differentiate the following functions of e to the power x. Okay, so let's take the first one. Fx equal to x cubed plus 2x times e to the power x. Okay, so first of all we have to apply the product rule, because there are two functions, this function and this function. So by product rule, f prime x is ddx of x cubed plus 2x times e to the power x will be equal to the first function times the derivative of the second times the derivative of the first times the second. Now ddx of e to the power x is just e to the power x, and here ddx of x cubed plus 2x, it will be 3x squared plus 2 times e to the power x. Now you see, you can combine them. I have this times e to the power x, this times e to the power x. You will factor e to the power x out. You get x cubed plus 2x plus 3x squared plus 2 times e to the power x. Now let's take the next problem. E to the power x divided by 1 minus e to the power x. So clearly we have to apply the quotient rule first. So applying the quotient rule, f prime x would be, so first the denominator square. In the denominator I have 1 minus e to the power x. So 1 minus e to the power x whole square. Then the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. Right? Now what is the value of ddx of e to the power x? It is just e to the power x. So it will be 1 minus e to the power x times e to the power x minus, what is the value of ddx of 1 minus e to the power x? ddx of 1 is 0 and ddx of e to the power x is e to the power x. So it will be 0 minus e to the power x whole divided by 1 minus e to the power x whole square. Right? So if you simplify this, you get e to the power x minus e to the power x times e to the power x. Then minus minus gets cancelled, you get plus e to the power x times e to the power x divided by 1 minus e to the power x whole square. So now they get cancelled and you will be left with e to the power x divided by 1 minus e to the power x whole square. Now let's take the next problem. Fx equals to x square e to the power minus 1 over x. Okay, so you have to apply the product rule because you have two functions. So f prime x will be ddx of x square times to the power minus 1 over x, right? Since you have two functions, so first function times derivative of the second plus derivative of first times second, right? Now ddx of e to the power minus 1 over x. So here the outer function is e and the inner function is minus 1 over x, okay, right? So ddx of, so the outer function is e and ddx of e to the power x is e to the power x. So we have, but we have to replace x by the inner function, so which is minus 1 over x. So it will be, if you apply chain rule, e to the power minus 1 over x times derivative of minus 1 over x plus derivative of x squared is 2x, so 2x times e to the power minus 1 over x. So this is equal to x square times e to the power minus 1 over x. Now ddx of minus 1 over x, if you take the minus out, you are left with ddx of 1 over x, right, plus 2x e to the power minus 1 over x, right? Finally ddx of 1 over x, x can be written as x power minus 1, so it will be times ddx of x power minus 1 plus 2x e to the power minus 1 over x. So since x power is minus 1, I can write this as, so the first term would be minus x squared to the power minus 1 over x times in ddx of minus 1 means minus 1 x minus 1 minus 1 plus 2x times e to the power minus 1 over x. So ultimately if you simplify, you will get x square times e to the power minus 1 over x times x to the power minus 2 plus 2x to the power minus 1 over x. So this will get cancelled. It will be left with e to the power minus 1 over x plus 2x e to the power minus 1 over x. Next, let's take the next problem. The next problem is D. Fx equals to sine square e to the power sine square x. So here you see, so there are many, so you have to apply chain rule multiple times. So first you see this thing can be written as sine of e to the power sine square x and whole square. So the outermost function is x square, right? So inside that, so the outermost function is x square. Inside that you have sine, inside that you have e, inside that you have again square, inside that you have again sine. So you have to apply chain rule multiple times. So first of all, when you apply chain rule for the first time, f prime x, so the outermost function is x square, and derivative of x square is 2x. So it will be 2 times what is inside. So 2 times sine of e to the power sine square x, right, times derivative of what is inside, that is sine of e to the power sine square x. Now this part is okay. Now let's do this part. Now the outer function is sine x and the inner function is e to the power sine square x, and ddx of sine x is cosine x. So it will be 2 sine e to the power sine square x. In place of this I'll have cosine e to the power sine square x times ddx of what is inside, e to the power sine square x. Okay, now this part is okay. I have to just do this part. Here now the outer function is e to the power x and the inner function is sine square x. So and ddx of e to the power x is just e to the power x. So it will be 2 sine e to the power sine square x times cosine e to the power sine square x times, so e to the power sine square x times ddx of sine square x. So finally we have to just do this, ddx of sine square x. Now the outer function is x square and the inner function is sine x. So it will be 2 sine of e to the power sine square x times cosine e to the power sine square x e to the power sine square x times 2 sine x, because the outer function is x square, so the ddx of x square is 2x, so 2 times sine x times ddx of sine x, and ddx of sine x is cosine x. So in the last step we'll have 2 sine of e to the power sine square x times cosine of e to the power sine square x times e to the power sine square x times 2 sine x times cosine x. Now let's take the next problem. Differentiate this function. So here again you see that you have to apply quotient rule. So if you apply quotient rule, so f prime x will be equal to the denominator square, so c e to the power x plus d whole square, denominator square, denominator times the derivative of numerator minus the numerator times the derivative of denominator. Right? So if you simplify this, you will get c e to the power x plus d times, if you take the derivative of a to the power x plus b, you will have a e to the power x minus a e to the power x plus b times, if you take the derivative of c e to the power x plus d, you will have c e to the power x. Okay, now you will have c e to the power x plus d whole square in the denominator. So now if you simplify this, you get ac e to the power 2x plus ad e to the power x minus ac e to the power 2x minus bc e to the power x. Right? So now 1 divided by c e to the power x plus d whole square. So they will get cancelled and you'll be left with ad minus bc e to the power x divided by e to the power x plus d whole square. C to the power x plus d whole square. Okay, so now let's take the next problem. Fx equals to square root of 1 plus x to the power minus 2x. Now here, what is the outer function? The outer function is square root of x and the inner function is 1 plus x to the power minus 2x. So by chain rule, it will be ddx of outer function. Now, what is the derivative of square root of x? If you remember, if fx is square root of x, then its derivative is f prime x half x half minus 1, so it will be half x minus half, so 1 by 2 square root of x. This is the derivative of square root of x. This is the derivative. So the outer function is square root of x and its derivative is 1 by 2 square root of x. So by chain rule, it will be 1 by 2. In place of x, we'll put the inner function 1 plus x e to the power minus 2x times the derivative of inner function 1 plus x e to the power minus 2x. Now this is equal to 1 by 2 1 plus x e to the power minus 2x times ddx of 1 is 0 plus ddx of x e to the power minus 2x. Right? Now ddx of 1 is 0. Now here applying product rule will be ddx of x times e to the power minus 2x plus x times ddx of e to the power minus 2x. Right? So this is equal to 1 by 2 plus 1 plus x e to the power minus 2x. ddx of x is 1, so e to the power minus 2x plus x times e to the power minus 2x times minus 2. So if I take e to the power x out, factor e to the power minus 2x out, I actually have 1 by 2 square root of 1 plus x e to the power minus 2x e to the power minus 2x 1 minus 2x. That can be your answer. Let's take the next problem. Fx equals to e to the power x minus e to the power minus x whole divided by e to the power x plus e to the power minus x. So by quotient rule, so first f prime x is equal to denominator square, so e to the power x plus e to the power minus x whole square, the denominator times the derivative of numerator minus the numerator times the derivative of denominator. Right? So this is equal to e to the power x plus e to the power minus x times, so ddx of e to the power x plus e to the power minus x. So by chain rule, this will be e to the power x. Now, see, here I have a minus. Now, ddx of e to the power minus x. Now, what is the value of derivative of e to the power x? It is e to the power x. So by chain rule, it will be e to the power minus x times the derivative of minus x, which is minus 1. So it should be minus of e to the power minus x. This step is important. Minus e to the power x minus e to the power minus x times. So here also derivative of e to the power x is e to the power x. And what is the value of derivative of e to the power minus x, it is e to the power minus x times derivative of minus x, which is minus 1. So it should be minus of e to the power minus x whole divided by e to the power x plus e to the power minus x whole square. So ultimately you have to simplify this, e to the power x plus e to the power minus x times e to the power x plus e to the power minus x minus e to the power x minus e to the power minus x times e to the power x minus e to the power minus x whole divided by e to the power x plus e to the power minus x whole square. You can leave your answer here. Let's take the next problem. H fx equal to e to the power k tan square root of x. Right, so here the outer function is e to the power x and the inner function is k tan square root of x. So f prime x equal to, so derivative of e to the power x is e to the power x, so it will be e to the power k tan square root of x times derivative of k tan square root of x, right? So this is equal to e, right, k tan square root of x times, now ddx of k tan square root of x, you can take the k out, times ddx of tan square root of x, right? So this is equal to e to the power k tan square root of x times k times ddx of tan square root of x. So here now the outer function is tan x and the inner function is square root of x, so it will be sec square, because ddx of tan x is sec square x, so it will be sec square square root of x times derivative of square root of x. So it will be ultimately e to the power k tan square root of x times k times sec square square root of x. Now ddx of square root of x means x to the power half, so it will be ddx of x to the power half, so it will be e to the power k tan square root of x times k times sec square square root of x times half x half minus 1, so it ultimately e to the power k tan, so ultimately it will be a tan square root of x, right? Times k times sec square square root of x times 1 by 2 square root of x. Now the last problem. x equals to e to the power minus 2x cosine of 4x. So here, first of all, you need to apply product rule. So f prime x will be first function times derivative of second plus derivative of first times second, right? So ddx of cosine 4x, right? So it will be by chain rule e to the power minus 2x minus sine 4x times ddx of 4x plus ddx of e to the power minus 2x. So it will be e to the power minus 2x times ddx of minus 2x times cosine 4x. So ultimately it will be equal to, so 4 minus 4 e to the power minus 2x sine of 4x minus 2 e to the power minus 2x cosine 4x. So this brings us to the end of lecture 7. So by now you should be able to do homework number 12. That is the natural logarithmic, the natural exponential function 1. So there is one more topic left for test 4, which is Newton's method, which I will discuss in my next lecture, and then we will be done for lecture 4 and also for test 4 and also for this course also. So after that, what we will do is one review for the finals before you take your final. So by seeing, if you do all these problems, you should be able to do homework number 12. So homework number 12 is based upon the exponential function which I have discussed in this lecture. So go through these problems, do homework number 12, and then tell me if you have any problems, and then you should be good. And so there is just one more homework or one more topic left, that is homework 13, that is about Newton's method, which you will study in the next lecture. Okay, thank you.